Hello, folks. I would like to present to you the works of meteorological station #ecMeteo. We will focus on the REST API interface that was built on the Python Flask HTTP server. Communication uses the HTTPS protocol. The web page uses certificates. Now, let's look at how the logging of station activity works. Log files for sensor measurements are stored in the home directory. The sensors on the meteorological station are tested every 5 minutes. Measured data is sent to data targets, the clouds, and each activity is stored in log files. Each cloud has a unique log file. The new update date will be at 10:30. Let's look at the current date of log files. And we wait for a time change. Until the log update, we look into the database by running the SQLite browser command. The data was processed, and we saw it being updated in the log file. The data is now updated in an internal database. Let's look into the database. Let's look at the database structure. The table API stores metadata about the sending process to specified targets. The table location stores the latitude and longitude of the meteorological station. The table, sensors, stores used ICs and lifetime data. The table, parameters, collects meteorological and special parameters used for sending to targets, clouds. The target table stores information about targets, the data clouds. Let's open the application Wireshark. We will use it for checking network communication and data encryption. The application Postman, which we used for testing REST API by generating HTTP requests GET, POST, DEL. So firstly, we create a new user with a password. All data is encrypted, so no plain password text is visible. The HTTPS requests are encrypted. Let's log in with the new user Meteo by HTTPS POST request. Access and refresh token are created. We copy them in Postman settings. Now we can review REST API data. Now we check the location information. Let's look at the data in the parameters table. Output data are in JSON format. Now, look at the sensor table data. Partial look at sensor number 1. And finally, the target table data. Target number 1 is on OpenSense map. Let's look at the web page where our first target is. We see current meteorological data and also their history. https://opensensemap.org. The next target is tmep.cz, ecMeteo cloud. Open that Stuttgart sensor community webpage. Target number 3. Focus on the location of the station. All targets use the same data, measured at the same measurement points. https://sensor.community/n The target number 4 is Meteo Cloud Akenza. https://akenza.io. Now for communication with the Akenza target, we use the MQTT messaging protocol. Akenza graphs. "24-hour graph". "7-day graph". And now let's check the new data in the database. From outside, we use HTTPS requests to catch the measured data incrementally. JSON formatted. The next HTTPS request doesn't give the output because no data was measured during a short time. Now back to user management. Logout user. Let's try to regenerate the access token by using an existing refresh token. In reality, it is in the reopened connection. The new access token will be stored in Postman settings. It's working as we are logged in again. Let's check it. We log out again. data output is not allowed. That was expected. Now we log in again and copy the access token to Postman settings. Now let's look at the list of registered users. There are 3 users. We want to remove one user from the database. We want to delete the ID number 3 test user. The user is deleted now. User test was deleted correctly now. Thank you for watching. The demo for testing can be found at the webpage https://meteo.ecMeteo.org. Postman templates for testing are stored in the header of the video.